welcome back to another show of From the Field. We got Scott with us today, which is always exciting. I believe I'm actually talking to an empty room right now, but it's the best empty room I've ever had. The 5 minute intro one we had, by the way, Scott, like it goes for like about 5 minutes, and then in the last like 30 seconds, it goes like a full on like gaming, like
Full on
drum beat and
production
stuff
mode.
like that. Yeah, it's like
Well done for those first scenes. It looked really cool.
it's we used to have old ones and they would like they would just say we stay at the top of the hour, and it's kind of like, well, we don't really say to make new ones. And people from when I first released them, like about 2 weeks ago, the audience was saying, "Oh, it sounds like a movie intro and everything like that." So I'm thinking I might have to actually do a little bit more tweaks, just so people don't think we're going to be like,
Well, it's
premiering a
that
movie or
exciting.
anything.
Like this
Hmm.
is up there with the blockbuster.
Exactly. So just to get everyone like some context, so I am Casey, your host for From the Field. We talk about all of the exciting things that we see in the field, and give best practices and how we actually see things. It's a very laid back show, so feel free to chuck in any comments or ask us any questions. Like we're more than happy to help out and stuff. So we are both located in Wellington, New Zealand. I'll let Scott give a little bit of background before we dive into what really got him into the IoT space, and why is he like vibing with it.
Thanks, Casey. Yeah, so senior solution architect here at AWS, and Wellington based. So we've got the first day of spring today. So bit of that spring hay fever coming through already. But I'm really excited to share what I've been getting into today.
Awesome. So what got you into IoT?
Good question. I've always had an interest in kind of electronics. Back in the early days, what got me into IoT per se was I had a garage door opener, one of those clicky ones, and it broke. Um, this was a couple of years ago, and I thought, well, bugger, if I can spend $150, $200 to replace it, or maybe this is a good opportunity for me to build something new and kind of digitize something in my house, start to get into home automation. So I had a little microcontroller lying around, so I loaded the SDK on it, loaded a certificate, and used the IoT Core device shadow, which we'll get into later, to represent I guess, an offline state of my garage door. And then I could use an API to update that offline state, which would then feed an instruction to the microcontroller to open and close my garage door. So that was pretty cool, being able to then take that API and build my own little web application and mobile application for my house. And so that's really kicked off. I found it quite an easy process, and I I've been prototyping devices since, and I want to share my latest one.
Nice. You were a lot more productive than I was in my youth. We had one of those like clickers for the garage doors as well, and we just tried to time it so when someone was walking out of the garage or walking into it, they'd hit the head. Um, so that's pretty much what I got up to my spare time, is try how to make life difficult for my friends and family. Uh,
Brilliant.
so what exactly are you going to be talking to us about today?
So yeah, we're going to focus around IoT is a really a broad subject, right? You can go all the way from the smallest chip device to full on cameras and computer vision and industrial IoT. So today we're going to focus on some of the microcontrollers and the operating systems that run on that, and then how to connect those up into AWS so you can start to push some data up.
Nice. Yeah, I played around with IoT myself, where where I had like a Jetson Nano, where I had uploaded a custom model, and that was used for a camera to decide whether or not there was a red tractor or a blue tractor. Something really simple, but
Yep.
just to get to get me across it.
The classic hot dog, not hot dog problem.
Yes, exactly. And I'm not very good at the whole email stuff, so I wasn't very good at detecting whether or not it was a blue tractor, red tractor, but I was very good at detecting if there was a tractor.
You're obviously from small town originally.
Uh, Nearly, maybe. I think in the global set of things, like Wellington is a small village.
Yeah, yeah, fair enough.
Cool.
So maybe we get into it and switch to
Yep.
some slides.
Sounds good. There you go.
So I guess I want to talk about something I've been um, recently doing with a customer as well, and um, really my steps, my thought process, and I'll show you a bit of a demo. But it really came from the fact that this customer, no one goes out to go and buy devices um, and set up a whole stack without a reason. They're normally trying to measure something on an ongoing basis or digitize how something works today. Um, so I guess when you're looking for ideas to solve those things that you want to solve, we want to be able to try out as many ideas as possible, so we can fail fast and fail a lot and fail well. So that means we can try out everything and learn what works and what doesn't. And I guess the faster you can iterate on those experiments and faster you can get feedback, then it's going to really reduce the R&D time that you spend on it, or your company spends on it. And yeah,
What's your Sorry to jump in there. What's your take on the whole buy versus build mentality when it comes to IoT?
yeah, great question. So I see the when you put certain components together and you come up with a really good prototype, and then you productionize that, all of a sudden that device now is worth quite a lot in the unit price. And then I find, I guess IoT vendors bring their own platform as well. So if you buy their devices, you have to also buy their data platform and stream data into there and drive the analytics and ML from there. That didn't really work for me because I wanted to have a bit more flexibility in how I use the data and which services I sent it to, um, and things like that. So the buy versus build is interesting, because if you've got time to spend on R&D, then you might be able to reduce your overall cost. But if you already know the solution to your business problem, then and it's on the off the shelf, then you can just go buy it, and have that solution today instead of waiting um, weeks or months for R&D. Um, and then I guess the whole evolution of this is once you once you have that device out in the field and you're starting to measure, what if you increase the number of devices to 1,000 or 10,000? Um, what kind of things could you then draw from that data? Um, as the Internet of Things grows, there's going to be billions of devices connected to the cloud, and we're seeing real strong um, uh, evolutions in connected cars and with the automotive industry as well. Connected cities have been around for a long time. We're seeing more and more industrial IoT. So I know of a company who are actually embedding IoT devices in the concrete they pour. So when they're making buildings, they can track the quality and the vibrations that that piece of concrete has seen, and then once they combine that with the thousands of sensors they have in a building, they can really accurately see what the stress points of that building are, and maybe produce some predictions on maintenance and things like that. So some really cool things, and I find it's often limited by your imagination in what you can pull once you have that scale of data.
And you're also seeing a lot of uptake in IoT connected devices, so to speak, in the residential. So you got fridges and smart TVs and stuff like that. They're all really embracing that trend, so to speak. I still have no idea why my fridge ever needs to connect to Wi-Fi, but apparently it does.
Yeah, I think that's part of the whole connected home. Um, People want to. anything. My dishwasher connects to the internet for some reason and tells me when it's done. Like, I, it's that's not bringing too much value to my life, but we're starting to see IoT outcomes being presented to average consumers, which is it's cool. It's a step, and I guess they'll be getting product feedback about what features and things they should build next into their products.
Yep.
And that's the thing, right? So that's the business impact is what I've found with what I've found IoT does for customers really is um, leads to greater efficiency in what they're doing today, um, like replacing that manual measurement task with an IoT device. And that helps the bottom line. So it makes you more operationally efficient. But then you can also, once you have a lot of those things, build completely new product and services, and that's net new business. So that increases your top line. So it's really it's not one or the other. It's a win-win, and that's why IoT and digitization is looking so good for traditional business. Is they can save on their cost of their human cost, and then they can find new ways to monetize the data they're collecting. Have you come across any good examples um, of this in your travels, Casey?
I've talked to a lot of businesses that want to use IoT or get into it. Actually, I was managing one of a company that is, I believe, a case study. But I'm not entirely sure, so I can't mention the name. But they essentially a whole entire business model revolves around doing IoT connected devices on like farms and stuff like that to track effluent, so, fuel and stuff like that, because fuel theft is quite a big one. So actually having a fuel tanker that is IoT connected to say, hey, it's 1 a.m. and I'm dispensing fuel. Uh, should I be doing this? And then the farmer can run out there with his uh, shotgun and briefs on, you know, like
The
the good old
small town
days.
Wellington stuff.
I think we're heading up towards the Manawatu and Waikato for that one,
Yeah, okay.
but maybe,
Cool,
I'm
that's a
no
good
one to
use
judge.
case.
Yeah, so there's use cases like that around, but yeah, definitely seeing a lot of people going into the IoT space and even just doing things such as like being able to use computer vision on the edge to read analog displays of data and then be able to pipe that back to a operational dashboard, because a lot of like industrial equipment that has to handle certain capacities, like they can't use digital
Right.
for
And
reasons like
and so
you've gone to.
yeah, you can find that external way um, to actually just use a camera. Yeah, that's quite cool. Neat. So let's get into how we think about IoT on our side in AWS. We've now got quite a lot of services in our product suite for IoT, and we do group them into three components or three categories. It's basically down to how do you connect and control your devices. So some of the devices you might actually send commands to and have that device take an action, like open or close a garage door. Um, how do you get the data coming in? So that might be you might be just measuring something simple like temperature. How to make sense of it? So maybe you're doing ML on the device, or maybe you're doing that on the cloud side and doing some analytics from there.
Yep. So a cool one from there would be like if your house gets too cold, then it shuts the curtains to
Absolutely.
keep the heat in.
Um, so you've got two devices there, right? You've got a temperature reader that is pushing information, and then you've probably got a rule in the IoT core side that says, hey, we've just gone over a threshold, so let's send a control message to another device.
Yep. And we will be doing I say we, but Scott will be doing a demo towards the end of this that will actually show all of these services we are talking about. So yeah, don't worry. Like if you're not entirely sure what we're talking about, like it will become a lot clearer as
Yeah,
time
yeah.
goes on.
Today we're probably going to focus on FreeRTOS and IoT Core. I can talk for hours on all the other ones as well. We've even got one there, Robo Runner, that is used to control robots, which is pretty cool. And IoT Twin Maker is something that's really really coming up and becoming really popular. So that's when you can upload a CAD model of say a kitchen, and you've got your coffee machine there and your microwave and your oven, and then you can overlay the information that maybe your coffee machine is sending into that digital world, and then have a digital representation, a twin of a real world, and then you can go back and say, okay, what temperature was the oven on Wednesday? Or when did it turn on? When did it turn off? And you can go back and forth in the timeline. So it's really cool
I've
for
seen,
factories and that sort of thing.
yeah, I've seen an awesome one with a brewery. It was awesome to look at, like because you could see in real time, like when they was doing exchanges between vats, and what temperature a vat is at and everything like that. It was cool.
That's cool. That sounds perfect for if a brew goes wrong, you can actually replay and see exactly which variable caused it to go wrong. That's quite neat.
Yeah, it was awesome. It was one of the few times I actually truly geeked out and didn't want to leave a customer.
Fair enough. We're all geeks. So, out of all those, what do I need to start building a device or a prototype? So, let's focus first on the software. Um, and it's important here that just want to do a bit of a definition check. Microcontrollers and microprocessors are a little bit different. So we see a microcontroller or an MCU as a single chip that is really for simple processing. So it might be a chip within a light bulb um, or a coffee machine, that sort of thing. But then you've got microprocessors, and they provide a bit more compute and process power. They might be doing extra logic or even machine learning on the device, things like cameras and TVs, things like that. So that means they run slightly different operating systems that are more suited for the platform. And for MCUs, customers use FreeRTOS or CSDK to connect devices, and then processors can use uh, Greengrass or the AWS IoT SDK, um, and that's an OS that we can talk about at some stage, but not going into Greengrass today. Let's look at FreeRTOS. So what is it? It's a embedded operating system that runs on microcontrollers. And FreeRTOS really leads the MCU RTOS category. RTOS is a real-time operating system. And AWS took over the stewardship of the open source project a few years ago. And we're actually quite honored that Richard Barry, who invented FreeRTOS about 20 years ago, has joined AWS as a senior principal engineer, and he's still working on FreeRTOS. So we're continuing to invest in that project, and so it's still in good hands. It's written mostly in C, which makes it quite easy to port around the range of different microcontroller architectures. You can see it's got over 40 supported already. And who's using a microcontrollers in FreeRTOS? Companies come to mind as companies like Traeger use it in their barbecue pellet grills to send temperature information to their cloud connected app. I know some of you will be keen on barbecuing at home, so that you.
Yeah, I got Bluetooth monitors for them. You just plug it in and then it beams it Bluetooth. It's awesome.
Oh, I see. Is that cloud? That sounds like local connectivity.
It is local connectivity. If you get the one that costs more, you can also get the cloud-based one. But
Cool.
I just kind of made it so I have a burner phone. I shouldn't actually call it a burner phone, but it's a phone that I don't use. That actually sits near the like the Bluetooth, and that actually has an app on it that then
Okay.
uploads that data to one of my own AWS
Okay.
accounts, and
Oh,
then
cool.
that will send me an alert. So I kind of
Hopefully
built
that
the
doesn't
cloud component
quickly
myself.
become a burnt phone.
It, a couple times it nearly has.
Cool. Yeah, and so then also Belkin use FreeRTOS in their um, light switches, the iDevices light switches that are integrated with Alexa. Um, so that's a real good example of one of the command and control use cases.
Yep. And do you want to talk a little bit more about what it's mean by inter-process communication? Since
Yeah. So this is a way that we'll go into the libraries, but a way that the OS can talk to different sensors and stream messages in, um, and things like that. We'll definitely go into the libraries and things that I'm running on mine
nice.
shortly. Um, so digging into more about what the OS includes, it's really the kernel that is the main draw card, and it's got a bunch of software libraries as well that make it easy to connect to cloud and things like that. Of course, you've got the security. So you want to be loading certificates onto the device that can authenticate with the cloud, and then it's got some really smart libraries to do over-the-air updates and code deployments and things like that. If you think about having one device, flashing the firmware or uploading new software is easy, but if you think about 100,000 devices, maybe in a million different homes kind of thing, pretty it's a pretty hard problem. So
I have a
there's some
customer
libraries that
suffering
make
from.
that easy.
So yeah, I have a customer suffering from the exact problem. They have like probably about 1,000 devices out in the field, and they're like, "Oh, how do we update them?" I'm like, "Well, you're gonna have to go out and update null to allow you to update them remotely." And they are not looking forward to it. But it's really the
Yeah.
only way forward. Is like you really want to be thinking about how you maintain these devices, like
Yeah.
at this stage.
And you should be doing that at the prototyping stage as well. Um, yeah, and cool to note that we actually provide commercial support for the open source project as well. So it is an enterprise ready OS, and it's obviously run in a lot of products today. Some of the devices we've actually got. This is off our public website. We've got devices that support it, um, and there's a long list there. So jump on and search for that. But let's talk about one I found when so I was looking to um, prototype something for a customer who wanted to measure pressure. Um, so I did a bit of searching as you do, and I found this development board here, and it's from a company called PyCom. It's called a GPY. Now it's PyCom have customized MicroPython um, to run on top of FreeRTOS, making it quite easy to develop on. You don't have to use C and things like that. Um, the PyCom runs an expressive ESP32, which is a common chip, and basically everything is on the chip, including the RAM and the radio modules and that sort of thing. It does have 3 radio networks, including LTE. So you can use it with Spark's recently released their Cat M1 network, which is a special IoT network that runs over their existing 4G network. Um, and then it doesn't have a USB port. So the device, the prototype I've put together, we're actually using a USB to TTL serial converter on a breakout board. So we can connect to it over USB.
And just for our international viewers, Spark is a telecommunication provider in New Zealand. So, you'll have similar companies over in Australia and whatever.
Yeah. If you are tuning in from somewhere internationally, drop us a comment and say where you're coming from, because we're really interested to see. So So I got the microcontroller, the thing that does the processing, and I still needed something that did the measuring of the pressure. So I did a bit more googling, and I found that Honeywell make pretty much every type of sensor that you could imagine. So I found a data sheet there on the left of a pressure sensor, and you can see it's about the size of a pencil head. Um, and this sensor has the right characteristics that I was looking for. So it does, I think it's 0 to 25 psi, and that's exactly within the bounds of what we need it for. So that's cool. And I did a bit more searching and found that Adafruit actually has this little breakout board. So they've taken the sensor and put it onto a breakout board, put some supporting components on there so you can so to make it easier to read the data coming off the sensor, and then you can connect to it through I2C, which is it's called integrated circuit protocol, which is basically a bus interface connection protocol. It's used for serial communication between that breakout board and the PyCon board, and it makes it quite easy to communicate with the sensor. Yeah, so 0 to 25 psi. I think standard temperature and pressure. It's about 14.7 psi at sea level. So that's right in the middle of what we're trying to measure. Let's have a look at what I've got. Uh, if we can change
Let
the
me just
camera to
make
make
you
this
bigger.
big. Yeah,
Yeah, if I can just make you a solo layout. There you go.
cool. I don't know if that's mirrored or not, but you can see we've got the PyCon board here, and it's got a chip and it's got a button to reset it. It's got an LED show the status. It's got a couple of ports in there to put various antennas. You got the LTE one and the Wi-Fi one, um, and I've plugged that into a breadboard, which is kind of a standard thing for doing bench electronics and playing around. There's my little sensor on the Adafruit breakout board, and my USB UART controller. So that's pretty cool. And I'm going to plug this in soon, and we'll see it starting to generate some data. Hopefully, if it chooses to work, that'd be fun.
Live demos is always a flip of the coin, right?
I know you always got a caveat.
Mm.
So that's cool. So that's the device software side of it. We can run everything we need to on the device, but to make it really valuable, we need to be able to send that to the cloud. One device's data is not that useful by itself. We're really looking for 1,000, 10,000 devices data to really make sense. So let's look at AWS IoT Core today, because that's the thing that really enables the connectivity and a bunch of the functionality that we need to communicate with our devices. So we've got the components are we've got an identity service there, which can generate certificates and issue certificates for authentication. You wrap policies around the certificates for authorization, basically telling a device what it can and can't connect to. And then we've got that device gateway there that provides a secure endpoint to connect your devices to, and that scales automatically. It's a managed cloud service within IoT Core. Then we've got a message broker, which processes and routes data messages to the cloud, and that's basically a managed MQTT broker. So MQTT is the protocol we use. Runs over HTTP, and it's a super efficient pub sub protocol that IoT devices choose to use. It's open source, so this is basically a managed broker for that. We've got the rules engine, so we can actually trigger actions on devices or route messages to other services. and I'll show you an example of that as well. And then the device shadow is actually something quite cool to talk about. So this enables applications to interact with the devices even when they're offline. So you can think of a device shadow as like a represented state. It's actually a JSON object, but it's a represented state in the cloud. So to give the example of my garage door, I had a device shadow for my garage door, and it would show you a desired state and a reported state. So when my mobile application wanted to open the garage door, it wouldn't go directly to the device. It would go to the device shadow and say, my desired state for the garage door is open. And then device shadow can look at the desired state and the reported state and go, oh, there's a delta here, there's a difference. So I'm going to publish a special message out on a MQTT topic that my device subscribes to and say, hey, there's a change in state requested. And then what my device can do is control my garage door. So open it up, make sure it's open, and then it can report back to the device shadow saying, hey, I've opened, the new state is open. So it's a really good way, because IoT devices in the environment, it's quite a noisy environment. So you need a way to deal with losses in communication or varying factors around environments. It's quite chaotic place to be for technology.
Yeah, Scott, we just got a question in. Can we use Raspberry Pi to ensure real-time data transfer to a server by using a GSM module rather than Wi-Fi?
Yeah, totally. So Raspberry Pi, I would put in the microprocessor category. It's got a bit more processing than your average microcontroller. So you could use the AWS SDK to do that, and it's got MQTT libraries that you can just publish messages, or you could install Greengrass on the Raspberry Pi if you needed a bit more functionality. Okay, moving on. We've also got a registry. We need, so one device is great, but what happens if we have 100,000 devices? We need a good way to be able to categorize and I guess create a bit of a device hierarchy, and search for a particular device. So that's what the registry does. And it can also do automatic device registration, things like that. And then device advisor is when you're building your prototype and you're testing things on your bench. Device advisor can run a series of tests against your device before you put them into production, just to make sure that that they're going to pass all the functionality that's expected on the AWS side. So that's a really cool way to test things before putting into production. Cool. What do you reckon? Should we have a look?
Yeah,
I reckon
totally
we should have a look. So what we've got today is we've got the ESP32, the PICOM device, and we are going to be measuring pressure, sending a piece of JSON over MQTT to IoT Core. What that's going to do is trigger a rule, and that is going to cause IoT Core to store that data in an S3 bucket. And then I've just got Amazon QuickSight, pointed it towards the S3 bucket so we can start to visualize some of that data. So what I'm going to do now is switch to, actually, I'm not going to switch, I'm going to switch to my console and show you what it looks like in AWS. Cloud economics, that's meant to not be there. Awesome. So this is the AWS console. I'm going to go into IoT Core. I'm just going to show you what, oh man,
It always
What my
happens. Come on, man. Federate quicker.
it was meant to be all refreshed. Unless they have a demo mode. Take two. We're going to jump into IoT Core just so I can show you what a kind of a device looks like inside the console. And you
Do you
can
want
set
to
up
increase? Do you want to increase the text size by 2?
1, 2.
There we
Okay,
go.
cool.
Lovely.
Nice. We've got a whole bunch of options down the left-hand side. So if we go to all devices, every device in IoT Core is called a thing, which is I think is quite a cool name of naming things because there's so many different types of things that you can use as an IoT device, and they could be anything. So I've got one called GDW Sensor 1. Let's click into that. And I'm going to click into certificates, and we can see that it already has a certificate created. What you want to do when you create your own device is create a thing, create a certificate, and then upload that certificate into the device, and the device will tell you, the device documentation will tell you where that should be. For mine, I have to load it into /USB/certs or something. No, /flash/certs. And then make sure I have the private key and the root CA, things like that. So I've clicked into the cert, and then around the cert, we can attach a policy. So the cert provides the authentication, and then the policy provides the authorization. So if we click into this, the third version is active. And so a policy is basically a policy document like you would see in IAM, and it is going to tell the device what it is allowed to and not allowed to do within AWS. So this one says it's allowed to do everything in the IoT service against everything. So obviously it's good for prototyping for my demo here, but don't recommend using this particular policy for your production device. Maybe you want to limit it down to a specific topic that it can publish to or subscribe to, using least privileges, least privilege principles. Cool. So let's close that down. So what I'm going to do is we've got an MQTT test client here in the console. So we can actually use the console to subscribe to our topics. It's really useful for testing and validating the things we're pushing to cloud. So I'm going to be publishing messages to a topic called reading/PSI. So I can just subscribe to that now. And we'll come back to this. Okay, I'm going to bring up some code.
Do you want to increase the text size again?
Okay. Yep. How about that?
There we go.
Right, so this is the code that was going to be running on my PyCom. It's already uploaded, but yeah, it's fairly easy to read Python. We're importing a bunch of libraries that are on the device already. We're connecting to my Wi-Fi at home. I've got a config file with my credentials and things like that in it. We're setting up the MQTT client with some configuration items. They're in a config file as well to make it easier. And then we're doing the first connection to AWS. We're then assembling a dictionary, or it's not a JSON object yet, but it's going to be. So we're assembling our message. So device ID is 1, and units is PSI. The data here is calling out to a library to get the pressure. Let's go check that out. So this is a library that I've written for the sensor. There's, depending on your sensor, there might already be a MicroPython library or one written in C, or This is actually ported from CircuitPython, which is a different type. But essentially, the sensor manufacturer will tell you, or the breakout board manufacturer will tell you which memory address that the sensor board is putting the value in. So you've got to load that in there, and then the next thing that I need is to tell the PyCom which pins that I've used, that I've plugged the breakout board into on the PyCom side. So I'm using pin 9 and pin 10, and you can get the whole pinout. I guess they call it a diagram on the website. Yeah, so not too much else we need for here. We're basically getting read from into, we're reading from the memory address into a buffer, and computing the PSI from there. Okay, so this is the Atom IDE. You might use something like VS Code, or I don't know if there's any other good ones, are there? There's a few, but this is Atom, and I like it because it's really easy to connect to the device. So I can just plug my USB into the controller here,
Yeah, made you
and
big.
made me big, and it's got some lights on, the blue lights, and then back on the code there, you can see it's already connected to my Wi-Fi. It's done the initial hello connection to MQTT. We're actually sending some messages. So we're sending 600 messages at half a second intervals. So let's jump back to the console and see if we can see them coming through. Look at that. So we're publishing messages to readings PSI, and we are subscribing to that here on the console. And we're getting readings what we'd expect. I'm a bit above sea level here, so it's making sense that it's a little bit above standard temperature and pressure. But maybe we can make this value change as well. I've got a syringe here that can, I guess we use this to simulate a pressure change, and a piece of tube. I'm going to put that over the sensor and see if I can do a quick shot of air to get that reading to come up.
This is where the live demo.
I'm not timing it right.
You just need it always goes wrong at this step.
Yeah. It's just getting getting a high reading up on the screen, really. There we go. There's
There
a
you go, you got
15.
15.
Pause.
Pause and go find it.
There we go. We got 15 PSI.
Yep. That's the most exciting thing that's happened to us the whole stream.
Yeah. Well, I was thinking of doing it by your breath, but you can actually only breathe about 2 PSI of pressure, or something real low like that. So that's pretty cool. What happens now? So maybe let's have a look at. Oh no, where do we go next? Should I show the
You should show
rule,
the
or
rules. Yeah, show the rules.
show the rule? Actually, I might show how easy it is to push a piece of code, and I'll give it another chance to break. So I might just refresh that so we can subscribe again, because the pausing kind of broke it.
See, this is how live it is. We just make changes on the fly to the demo.
Yeah, it's better that way.
Yeah, it's funner when things go wrong. Otherwise, it looks too clinical.
It might just be a video recording, but it's not. Oh, we got a connection reset. I broke something. Okay, so I'm just going to
See, things have already gone wrong. You're gonna have to reset the whole device.
what I want to do is I'm trying to control C out of this. So here we go. So we're back to the REPL prompt. So it's quite cool that I can actually get a prompt on the device. This is REPL is read, evaluate, print, and loop. So I can do print. I can't say the dog for a walk. Print hello, and I can actually, this is the device running this. So I can also change my code up here. I got a message to watches. Cool, that looks relatively valid. And then I can just push this upload project, or maybe not, it's disconnected. Upload project. There we go. And it's writing that file now to the board. It's doing a soft reset here, and then it's going to be running. It's got actually a new IP address, and now it's running that that upload. Let's see if it's going to start sending packets. Cool. We're sending packets now. Switching back to our MQTT subscription, and we can see that new message coming through, which is pretty cool. So that took like 10 seconds to change the code, push the code, and see the actual results. So real quick.
Yep. Rapid prototyping makes life so much easier. Like when you have to wait 2 minutes for a change to come through, it's just painful.
Yeah, that's right. So let's have a look at that rule now. What happens from here? So we are receiving those that JSON data, but now we're going to do something with it. So let's come to message routing and have a look at rules. So here's one that I created earlier, just to send things to IoT Analytics, which is a analytics service specifically for IoT. And you can see you can actually run SQL against all of the messages that are in this specific topic. So you can get really, really granular with it. And then once something matches this SQL statement, we have actions that we can do against the messages. And one of the actions is sending to IoT Analytics, but another one is sending to an S3 bucket. So that's good. I'm sending JSON objects into an S3 bucket. I know that I can now do stuff with that data there. So I have, I'm using Amazon QuickSight, which is our visualization tool for analytics. And it's refreshing. And basically, I've pointed QuickSight to my S3 bucket and said, read all that stuff. Oh, it's on an import. Cool. And so here we can see a distribution of the data that we created before. Quite a few data points, most of them around that 14.7 standard temperature pressure, but we've got some outliers here as I was pushing air through. So our max was 16.47 psi when I was doing those tests. But you can do really anything with this data from here. Awesome.
Nice. Is that the demo wrapped up?
That's the demo wrapped up.
Awesome. So if you have any question for Scott, it's not very often that you get someone like him that you can holler any questions at. So definitely go ahead and ask us some questions. In the meantime, if you want to learn more about these services, we do have a number of training options. So if you go to skillbuilder.aws, I believe the URL is, if you want to actually type it into your browser, just so they can see it. Then like you can actually select that you want to learn more about IoT as a subject, and it will build out a nice like a curriculum that you can go through in your own time. And that allows you to have a lot more targeted learning. And then also if you go to workshops.aws, I also believe is the URL, there we have a number of curated workshops that if you want to actually get hands-on and actually just work for a workshop, a guided workshop that is in your own AWS account, then that's also another really good way to learn. Even working for AWS, like we have so many services, like we have over 200 I believe now, and like I go through these workshops as a way to actually get that first initial like understanding of how the console's laid out, some of the common trip points, how we're expected to interact with that service. So they're really, really good starting points, and from there you can start, setting yourself, tasks such as how do I build X, Y, and Z by incorporating this new skill set. And yeah, as I was practicing with doing that machine learning on the edge with the Jetson Nano, I did the same thing. I pretty much took one of those workshops and started hacking and abusing it, because like any developer out there, we never start from scratch because that takes effort. Always start from someone else's code base. It's great. Um, but yeah, and just on that front, like in New Zealand, I'm not entirely sure about everywhere else, but I know it's also in Australia that everyone is really, really just looking for cloud engineers and cloud architects, people that understand cloud in general. Like they're in hot demand. Yeah, that you could pretty much, like, if you have certifications in AWS or one of the competitors, I won't mention them, but yeah, definitely, like, you are in very, very high demand. Scott, do you have anything to put in on that front?
No, just thanks very much for hosting this show, Casey. It's really useful for a wider community, and feel free to anyone watching, reach out to me if you want to know more about IoT, or just want to get super nerdy on building devices.
Yep. And we also have an AWS New Zealand technical group on LinkedIn. So if you are local or want to pop over to work in New Zealand, we are always happy to have people from all over the world come and live in New Zealand and also offer their brain power to us. So definitely, if you're interested in joining AWS or a business in New Zealand, yeah, definitely reach out into the AWS New Zealand technical community group in LinkedIn. That would be awesome. And yeah, thank you, Scott, for taking the time out of your day, especially your lunch break. And now we're eating into the walking time for your dog. So
Yeah,
I also apologize
gotta
to
go
your dog.
stretch his legs.
Yeah. So thank you very much for sharing your knowledge with us, and everyone that is watching us. Hope you had a good time and you learned something. For now, Matiwa.